Hello. This will be a demonstration of proposition 21 of book 10 of Euclid's Elements, which says that the rectangle contained by rational straight lines commensurable in square only is irrational, and the side of the square equal to the same rectangle is also irrational, and let the latter be called medial. This is the first proposition in which we deal with irrational straight lines and discover a category of irrational straight lines. The medial straight lines are the first kind of irrational straight line. As the proposition says, we're given two rational straight lines, AB and BC, which are commensurable in square only, unlike proposition 1019, in which they were commensurable in length. AB and BC here are both rational still, but commensurable in square only. That is to say, they are incommensurable in length, but the squares on them are commensurable. And these two rational straight lines, commensurable in square only, will contain the rectangle AC. What we want to prove then is that this rectangle AC is irrational. And furthermore, that if a square be made equal to this rectangle, the side of that square is also irrational. And we will call the side of such a square a medial straight line. Now, just as in the previous two propositions, we will begin by constructing the square on AB. We will call it AD. We can, of course, construct such a square according to proposition 146. Now, because AB is a rational straight line, we know from definition 10.4 that the square on it, because AD is the square on AB and AB is rational, we know from definition 10.4 that the square AD is also rational. Now, because AB and BC were given as commensurable in square only, they are incommensurable in length. And because of that, because AB is equal to BD, because they're both sides of the same square, definition 122, because AB is equal to BD and AB is incommensurable with BC, BD also is incommensurable with BC. Now, DB is to BC as the square AD is to the rectangle AC. We know this from proposition 6.1. This square AD and the rectangle AC, they are under the same height, that is, they are in the same parallels, so they are to each other as their bases. That's what proposition 6.1 tells us. It's because DB is to BC as the square AD is to the rectangle AC, and BD has been shown to be incommensurable with BC, then we know from proposition 10.11 that the square AD is also incommensurable with the rectangle AC. Now, in step 2, we had shown that the square AD was rational, but because the rectangle AC is incommensurable with this rational area, by definition 10.4, the rectangle AC is irrational because it is incommensurable with the rational area AD. Definition 10.4 tells us that the rectangle AC is irrational, which also means that the side of the square equal to the rectangle AC, that straight line on which the square is equal to the rectangle AC, that straight line is also irrational, again, according to definition 10.4. And this is what we set out to prove. We set out to prove that the rectangle AC, as given, contained by rational straight lines AB and BC, commensurable in square only, that this rectangle AC was irrational, from which it follows that the straight line, the square on which equals the rectangle AC, is also irrational, according to definition 10.4. And we will call such a straight line the square on which is equal to the rectangle contained by rational straight lines commensurable in square only, we will call such a straight line medial. Now this is what we wanted to accomplish in the proposition, so we are therefore done with this proposition, therefore, etc., Q, E, D. This is the first proposition, as I said at the outset. This is the first proposition in which a kind of irrational straight line is found and named. Now in this resides the paradox of Book 10, that a logos be given of the alogoi, that one rationalize the irrational, that one account for the unaccountable. The name irrational is not a name that Euclid came up with. It has its origins in the earlier Pythagorean tradition, and they called these straight lines irrational because they were seen as unaccountable. That's what alogoi, one way you could translate the Greek word alogoi, which is what these straight lines in these areas are called. You can translate it irrational, as Heath does, but you can also translate it as unaccountable. And this was the attitude towards such straight lines. The square on the diagonal was at least commensurable with the square on the side, even if the side wasn't commensurable with the diagonal. But such straight lines as the medial straight line, they weren't even commensurable in square with the side or the diagonal. So they were seen as these wild straight lines. And so were called irrational or unaccountable. But here, what Euclid has accomplished in this proposition, and what he will continue to accomplish throughout the course of Book 10, in fact, I believe that this is the main project of Book 10, is the taxonomy of irrational straight lines. In a way, sticking it to the Pythagorean tradition, which called these straight lines unaccountable, wild straight lines, that you could not rationalize them. And what Euclid is doing in Book 10, what he has for the first time done in Proposition 10.21, is account for them. Given one kind, he has found a kind of irrational straight lines, he has named it, and he has found a definite origin for some irrational straight lines. The straight lines are called medial by virtue of that origin. How one would find the side of a square equal to the rectangle AC is by taking the mean proportional of AB and BC. Just as Proposition 613 tells us, we would take the length AB, we would put the length BC in a straight line with it. We would then erect a semicircle on AC and then erect a perpendicular from B, reaching to the semicircle at some point, say D. And then the square on BD, we know, is equal to the rectangle contained by AB and BC. But the rectangle contained by AB and BC is the rectangle AC. And so the square on BD is equal to the rectangle AC, from which it follows, according to Proposition 6.17, that when you have a rectangle such as AC equal to a square such as BD squared, you can then say that the side of that square is a mean proportional to the sides of that rectangle, that AB is to BD as BD is to BC. And because it is a mean proportional or a middle proportional, it is called medial because it sits in the middle of AB and BC. A couple notes before I end the video just on notation. This is the first proposition in which we have seen irrational straight lines. So I will remind you how I will be notating irrational straight lines or irrational areas is by writing an I and then a rho. Rho has so far signified that a straight line or an area is rational. If I put an I in front of it, I mean to designate by that the straight line or the area following it is irrational. But more importantly, for the first time, we are dealing with the side of a rectangle. Now, rectangles don't exactly have sides singular. You can't say that the side of rectangle AC is AB because, well, BC is also necessary to determine the rectangle AC. But when Euclid talks about the side of a rectangle, he means the side of a square equal to that rectangle. And then, of course, side would be singular because squares only have one side. They're equilateral. And so whenever Euclid talks about the side of a rectangle, the straight line, the square on which is equal to a given area, I will denote by that, not the standard way that I believe I have noted sides by, which is by taking the straight line AB and just putting a bar next to it. Instead, I will be denoting the side of a square equal to a given area by a square root. Indeed, this is what the side of a square equal to a given rectangle corresponds to. Corresponds to taking the square root of that area, because then when you build a square on such a straight line, you get a square equal to the given rectangle. So again, whenever Euclid talks about the side of a rectangle, I would denote that as here, for example, by drawing a radical or a square root sign above that rectangle. That's all I've got to say about this proposition. I hope this was a good introduction to the taxonomy of irrational straight lines, because, as I said before, this is the project of Book 10, to categorize and order irrational straight lines. So this being the first proposition dealing with that, I hope I did a good job not only explaining the proposition, but its significance to the broader landscape of Book 10. But if you have found my explanation lacking, the comment section is always open, so you can just ask me a question, and hopefully I can explain it better than I have here. That's all I've got to say about this proposition, so I will end the video here and move on to proposition 1022.